Optimization. Maximizing or minimizing. What have we been looking for? The maximum and the minimum. That's what optimizing is. What is the maximum profit I can make? What is the minimum amount of material I need to use in order to make this particular object? Very good, realistic applications. And that's what your homework's going to be. That's what some of these are here. There are also going to be some esoteric ones as well. But really, it's about maximizing and minimizing. What's the best? What's the worst? One of the homework problems, I do believe it's for this homework. It's either here or it's in the chapter review. I can't remember. I absolutely love it. Show that if your profit is this and your revenue is this, or show that your costs are this and your revenue is this, the best your business could do is break even. I love that problem. You have an equation that describes the money you're bringing in. You have an equation that describes the money you're spending to make this particular thing. The amount coming in minus the amount going out to your profit. You show that using those equations to describe that situation, the best you can do is break even. So your maximum gives you 0. That's the best you can do is break even. No profit. Not a good idea to get into that business if that's the best you can do. So you can kind of start to see a little bit where, okay, this stuff is important. And we do scratch on the surface in here. Many universities have calculus for specific majors. I know Humboldt State used to, I don't know if they still do anymore, but they had a calculus for nursing majors. They had a calculus for, because they didn't have pre-med, but they did nursing. They had calculus for the life sciences, which was all the zoology and biology and that kind of stuff. They had calculus for business calculus. A lot of schools still have business calculus. And their problems are tailored, these problems here are tailored specifically to those types of things. One of the things I like about your book is it throws in a few really neat, interesting problems where you'll have, half of a column is one problem, but 3/4 of that one problem is explaining the background to what you're doing. And it gives context to what you're doing. And I like that. Okay. So when we're doing optimization, one, you need to read and understand what the problem is asking you. Okay. You need to write a function whose extreme value will give you the max or min. The important thing is that needs to be in one variable. Often the problems you get come in 2 variables. You need to do some substitutions, and you'll do that in here to get it in one variable. You cannot maximize or minimize something with more than one variable in it. It has to be down to one variable. Okay. Graph and find the reasonable domain. Okay, we'll do it other ways. You'll have to find, if you're working for a volume, what's the maximum volume, what's the minimum volume you can have. Somewhere within that range is where our answer is going to be. Find the derivative is equal to 0, it does not exist, and look at the endpoints. Endpoints may be important on this. Find the absolute max or min using the first or second derivative test. I never use the second derivative. Just set up a sign chart and we'll find the max or min. And does your answer make sense? And I'm going to be honest with you, every once in a while, you do the math correct and the answer doesn't seem to make sense, but if you stop and look and stop, well, yeah, I guess maybe it does, but at first it doesn't sometimes. I've had some who I've worked it out and looking at them going, that can't be right. Go back and look at the math and look at the math and look it over again. Everything was good. Stop and think about it. Yeah, okay, I guess it is all right. So, but you want to look at your answer, see if it makes sense. Okay, example number 1. What is the largest area possible for a rectangle whose perimeter is 8 meters? So we're solving for area. What are we trying to maximize? Area. Area is what? Length times width. How many variables do we have here? 2. We need to make it 1. Okay, we need to make it 1 variable. Now, what's already here is 2x plus L. So I have one side x. What is my other side going to be? Okay, so I need to solve it for 1 variable. So if I go back up and look at this one here, this equation here, Our perimeter is, we're given some information, right? Our perimeter is 8 meters. So this means our perimeter is 8. So we have 8 equals 2x plus 2L. Okay, do you see where that comes? Do you see where I get that? Okay, so perimeter is 8. If one side is x and the other side is L, 2 times x plus 2 times L gives us our perimeter, right? I want to solve for L in terms of x. L equals something else, x. That's what I need to do first here. Before I can do any optimizing. That's what I need to do first. So the first thing I'm going to do is solve that equation for L. Divide everything by 2, make the number smaller. 4 equals x plus L. So L equals 4 minus x. So I have my 2 lengths, or my 2 dimensions. X and 4 minus x. And if you have this as x, and this is 4 minus x, and you add all of them together, what do you get? 8. Right? So that's our perimeter. So our area is length times width. So our area equals our length, 4 minus x, times our width, x. This is what we are trying to optimize. I want the largest possible area. Okay, I want the largest possible area that I can find. What's the smallest area I can find? What's the smallest area? Think about it. No. I can have an area. I can have one even smaller than that. In theory, I can have an area of 0. If my width is 0 and my length is 4, I have an area of 0. What's the other dimension? So the smallest my width could be, the smallest x could be. X has to be just larger than 0, right? What's the largest it could be? What's the largest value I can have? What's the largest it can be here? 4. Because if I put in 4 for x, what do I get here? I get 0. So my domain is between 0 and 4. So when I solve my optimization problem, the only numbers I'm going to worry about is any value I get for x between 0 and 4. Anything else is irrelevant. It's outside my realm of possibilities. I can't have a side length less than 0, or I can't have x be less than 0 and x not be larger than 4. Because if it's less than 0, I get a negative width. That's not okay. And if it's larger than 4, I get a negative length, and that's not okay either. Do you understand what I did there? Do you understand that? My domain limitations. This is very nice to figure out the domain limitations if you can before you get started doing optimization, so you know anything you can throw out if you get an answer that doesn't work. Right now, we know our minimum area. Our minimum area is going to be 0 at the endpoints. So anything in between is most likely going to be a maximum. Okay, and usually this is the way it works out. Now, when I want to take the derivative of this, I want to make it easy. Distribute the x. And then take the derivative. A prime equals 4 minus 2x. And when in doubt, set it equal to 0. So 4 minus 2x equals 0. 4 equals 2x. X equals 2. So, is this a maximum or is this a minimum? It's probably going to be a maximum, as we figured out when we looked at the endpoints. But how do we make sure? Sign chart. Oh, please, sign charts. Oh, A prime, there's 2, there's 0, there's 4. Between 0 and 2, if I plug a number between 0 and 2, let's say 1. 4 minus 1, that's 3, that's positive. Number larger than 2 but smaller than 4, 3, makes it easy. Pick easy whole numbers if you can. 4 times 3 is 12. Minus, wait.
I plug it into the derivative.
I plug it in the derivative, my bad. So I put 1 in here, it's still positive. If I put 3 in here, I get a negative, thank you. My bad, a little off this morning. So that means my area is increasing until it gets to 2 and then starts decreasing. So I have a max at x equals 2. But does this answer my question? What is the largest possible area? That's my question. So answer the question. No, I just came up with one of the 2 dimensions. What's my other dimension? Okay, but if I found x was 2, what's if I found the width is 2, what's my length? 2. So it's a 2 by 2, which is a square. And if you didn't know that a square is the largest possible area of a shape with a given perimeter, shame on you for not knowing that one already. Area equals 2 times 2 equals 4 meters squared. Yes, actually the largest area, if it's non-rectangular, is a circle. The item with the largest area of a fixed perimeter is a circle. Second is a square. Actually, it's a polynomial, but you get that. But a circle. But if it's a rectangular shape, it's a square. If it's non-rectangular but not able to know the shape, it's a circle. You have a given perimeter. So if you have a length of fence and you want to make a dog run, make a circle. That'll give them the most area. Okay. Ooh, I like this one. This is one of those esoteric ones I was talking about, so I love it. Okay, a rectangle has its base in the x-axis, and its upper 2 vertices on the parabola 6 minus x squared. So I want to kind of sketch the parabola a little bit. First thing is, what's my y-intercept? 6. And what are my x-intercepts? Where is 6 minus x squared equal to 0? Square root of 6. Yeah, plus or minus square root of 6. What is the square root of 6? 2 point something, right? And it's more than 2 and less than 3, somewhere between 2 and 3. I don't really care where. I just want to have someplace between 2 and 3. So I have my parabola. Okay. And what it's saying is, and this is probably the most difficult thing for students to recognize, is what is the question asking me? What is it really saying? So I've got my parabola, and it's saying, hey, I've got a rectangle in here. And it says, what's the largest area of that rectangle that will be inscribed in such a manner? Now, this point, these 2 points here, could be anywhere along the parabola. It could be tall and skinny. It could be long and skinny, long and short. You know, to get at. Doesn't matter. What we have to do is we have to find the dimensions of that rectangle. So, area, length times width, or base times height, or however you want to work it. It's really not that difficult at this point. I work off of one of the coordinates. Now that coordinate, I don't know what the values numerically are. I do know that the x-coordinate is x. Whatever that ends up being, it's going to be x. The corresponding y-coordinate is going to be, what is y? 6 minus x squared. How do you find y if you know x? You plug it into the function, right? So if I know what x is, if x is 3, how do I find y? Ooh, put 3 in for x. I don't know it's 3. I'm saying what if it was? I have no idea what it is. Okay? Does that make sense? Do you understand?
Yeah.
So what is y? Y, because it's an xy coordinate, right? And x I have y. What is y? It's 6 minus x squared, because the equation is 6 minus x squared. How do I find the area of that rectangle? That's just the coordinate that provides me the dimension, helps me find the dimension that I need. Now, this length here is one of the dimensions of my rectangle. And I know it's not perfectly symmetrical, get over it. It would be what? 2x. Because from 0 to here is x, so this whole length would be 2x. So I get 2x. That's my length. What's my height? 6 minus x squared. This distance here is my y. The corresponding y that goes with that x value. 6 minus x squared. Yeah. What do I want to do? I want to find the largest. Largest. I want to maximize. How do I maximize? You find a critical point and see if it's a maximum or minimum. Once again, make it easier on yourself. Take the derivative. Distribute first. Area equals 12x minus 2x cubed. A prime, 12 minus 6x squared. Okay. And then, so I set that equal to 0. I get x equals plus or minus square root of 2. But we're dealing with areas. We only need to worry about the plus side. Do the minus side, it'll still work okay, but root 2 is really what we need. We don't need to worry about the plus or minus. So this is really just the plus part. Set up a sign chart. What's the smallest I could actually have? What's the smallest x could be? 0. What's the largest it could be? Square root of 3. Right? Okay. From what we solved here, square root of 3. So, pick a number between 0 and square root of 2, 1. Put it in the derivative, I get a positive. Something larger than the square root of 2, but less than the square root of 3. Is that right? No, square root of 6, sorry, my bad. Square root of 6, not square root of 3. My bad, square root of 6, thank you, my bad, thank you. Thank you, my bad. I'm having a slow morning, okay? Get over it. But I fixed the problem. Okay, between those two would be what? 2. Because the square root of 4 is between the square root of 2 and the square root of 6, right? Square root of 4 is 2. So I put 2 in here. 2 squared is 4. Gives me negative 24. I get a negative. So I have a maximum at x equals the square root of 2. So I have a max at x equals square root of 2. So my area is 12 times the square root of 2 minus 2 times the square root of 2 cubed. Isn't this lovely? Okay, the square root of 2 cubed is actually 2 root 2. 2 root 2 times that, so I end up with 12 root 2 minus 4 root 2, which means I have 6 root 2. Eight root 2. I was painting half the weekend. Those few lessons just got to me. Questions? painting over a mural in my new garage that was left by the previous owners. That was really stupid and ugly and very childish and didn't want it on my wall, so I painted over it. Not my kid. They weren't my kids. Why would I want to keep something that was painted by somebody who was not my kids? They weren't my kids. Okay. All right. Now you have fun. Find the dimensions of a triangle with maximum area if the hypotenuse is 10. Okay, what are we trying to maximize? Area. And area equals 1/2 base times height. Do I have any arguments about that? Good. Because my husband, one kids always argue that. No, it's not. It's based on type divided by 2. I know, it's the same thing. They don't get that. Okay. How many dimensions do I need? I need base and height, right? I don't have those. But it is what kind of a triangle? It's a right triangle. How do I know it's a right triangle? Because it's got a hypotenuse, and only right triangles have a hypotenuse. No other triangles have hypotenuses. Only right triangles have a hypotenuse. Which means that we get to use the Pythagorean theorem. Woo! So if I call this X, and I call this Y, fine, I'll call it A and B just to make somebody else happy. Oh, no. I'm going to call it B and H for base and height. Yeah, here's the problem. I want to maximize area, but I need one variable for maximization. I need to either write base in terms of height or height in terms of base. Which means I do have to set up the Pythagorean theorem. B squared plus H squared equals 100. Why 100?
10 squared.
Okay. I'm going to solve that one for B in terms of H. H squared equals 100 minus B squared. H equals the square root of 100 minus B squared. So that means this side here is actually the square root of 100 minus B squared. Ooh, now I have one variable. And I'll work down here so I have room. My area equals 1/2 base times the square root of 100 minus B squared. Ooh, yes, ma'am.
You make that 10 minus 2.
No, you can't. You cannot distribute square roots across subtraction. Only across multiplication. And shame, shame, shame on you for doing that. Okay, we're going to pause. Okay, we're done humiliating students. Now we can move on to the problem. Man. No, but I get that. And it is a dangerous thing. You have to be careful. You cannot distribute square roots. You cannot distribute powers across addition or subtraction. Multiplication and division, yes, but not addition and subtraction. For ease of taking the derivative, which isn't going to be easy anyways, 1/2 B 100 minus B squared to the 1/2 power. Now is where the fun begins. Taking the derivative. A prime is equal to, I have a product. First term, second term. So the derivative of my first term is 1/2. So I have 1/2 times 100 minus b squared to the 1/2 power plus my first term, 1/2 b, times the derivative of my second term, which is 1/2 times 100 minus b squared to the negative 1/2 times negative 2b. All right. I know, got to limber up for this one. Okay, so I'm going to pull out like terms. A prime. Oh, if you want to set this equal to 0 and solve it as it is, by all means, feel free. Knock yourselves out. I'm not. So I'm going to take a 1/2 from each term, and I'm going to bring out a 100 minus b squared from each term. What's my smallest power? Negative 1/2. So I bring out the smallest power, which means that disappears completely. And this becomes to the first power. Because 1/2 minus negative 1/2 is 1. Okay. Which means I have left, the stuff I have left gives me 100 minus b squared. That's this. And then 1/2 minus 2. I have b times 1/2 times minus 2b gives me another minus b squared. So I get 100 minus 2b squared over 2 times the square root of 100 minus b squared. And I can actually simplify that another step, right? Yes, what question? Right. So 1/2 and the negative 2. So I have a 1/2 b here and a minus 2b there. Gives me a minus b squared. Divide everything by 2 to simplify that down just a little bit further. A prime equals 50 minus b squared all over the square root of 100 minus b squared. Now, I do have a domain issue. I can't be larger or smaller than 10, but that kind of goes with the original problem. B can't be bigger than 10 or smaller than negative 10, but I don't get a length anyways. So 0 to 10 is my maximum and are the two endpoints for my domain. Because I can't have a length larger, I can't have a length smaller than 0. And I can't have larger than 10, so I hypotenuse is the biggest side of the triangle. We already know that's 10. So 0 to 10 is my domain. I have to find somewhere in between. It's undefined where the denominator is equal to 0. The denominator is equal to 0 at plus and minus 10. That's outside my domain. And then, so my numerator, where's that equal to 0 at? 50 minus b squared is equal to 0 at b equals the square root of 50. So one of my dimensions is the square root of 50. We go back up here. I solve for my base. Square root of 50. What's the other side? Square root of 50. So that's isosceles right triangle. How does an isosceles right triangle relate to a square? Yeah. Yeah. What does the square root of 50 simplify down to? 2 root 10. How do you find the hypotenuse? If I have a 2 root 10, 2 root 10, root 10, isosceles right triangle. Questions? Oh, we got enough time for that problem.
Wait, doesn't it ask what the
Yes, we do. It actually.
Find the dimensions. And then the maximum area. So what is the maximum area? Square root of 50 times square root of 50 is 50. So that's for the dimensions and the area. So the dimensions are root 50, and 10. The area is 50. Or actually half of 50, 25. Yeah, half of 50. 1/2 times root 50 times root 50. 25. Classic. Oh my God. This is your absolute classic problem. I cannot tell you how many times this question has been asked over centuries. Yeah, you guys did do something like this last year, didn't you? Didn't freak out? Yeah, you did it using a calculator to solve it, right? Yeah, no, we're going to use calculus.
I don't like that.
Actually, I think personally, the calculus I do believe is easier and will give you a more exact answer than your graphing calculator generally can. Generally speaking. Yeah, interpreting the graph, finding the points. Graphing calculators do very, very well. However, they do have issues giving coordinates as well as this one. And knowing how to solve this problem might just help you win a contest. Okay, as you know, you have done this problem before. You have a rectangle that is 8 by 12. No, man, that's really bad. And what we're going to do is we're going to cut out a corner from each edge and fold it up to find the maximum volume. So we need to figure a couple of things. We need to find an equation for volume. We need to find our domain. What is the smallest, if we call what we're cutting out x, what is the smallest we can remove? 0. So our domain, 0 to what? What's the largest we can remove? If I'm taking off from this side and I'm taking off from this side, what's the most I can take off? 4. Because I can't do more than 4. I can't cut 5 inches because then I can't cut 5 inches on the other side because I got 3 left to cut. So my maximum is 4. So my range of my answer has to be between 0 and 4. Okay. I need to find an equation for my volume. So volume is length times width times height. I actually like to do the height first, x, because if I fold it up, the side that I cut out, the length that I cut out, if I fold it up, that's how tall it's going to be, right? And then my width is going to be the distance between my two cuts, which would be what? 8 minus 2x. And my length would be the distance between those two cuts, which would be 12 minus 2x. And that's my volume. Now, multiply it out before you take the derivative. Do not do the derivative as it stands. 8 times 12 is 96. And then 2 times 12 is 24. 2 times 8 is 16. 24 plus 16 is what? 40. And then 2x times 2x plus 4x squared. However, I still have the x in front, so my volume, that's actually all times x. So my volume is 96x minus 40x squared plus 4x cubed. And when in doubt, what do you do?
Set it equal to 0.
No, you don't set that equal to 0. You take the derivative, set it equal to 0. Do so. And I can all but guarantee that this is not factorable. I do not expect you to use the quadratic formula. These things are wonderful. You could, I wouldn't. This is a lot more exact. I would use a solver. I don't know about TIs. I do believe TIs will solve polynomials and give you the factors as a polynomial. You should find out because I don't use the solver. When I have a polynomial, I never use my solver. When I have a polynomial, I use my on mine. There's a way to solve polynomials specifically. Yeah, I can punch in all I have to do is punch in 12, -80, 96, solve, and it'll give me my solutions. No, I don't have a TI though. I got a Casio, and HPs will do it. I'll show you how. It's very easy. Yeah, if you've got a Casio, I can show you on a Casio. Oh yeah, piece of cake. We'll take like 2 minutes when we get done with this. I'll show you how to do it on the Casio. TI, I don't know. Go online because there's smarter people than me and explain how to do stuff online. Okay, now, so these are my solutions. I got a problem. Outside my domain. Right? Outside my domain. So this is going to be my maximum. And then I believe the question asks for the dimensions. Find the size the square should be cut from each side. Okay. And then find the volume to the nearest tenth. Take this, plug it into the volume formula. Find your volume. We're almost out of time, so I'm not going to go any farther today. We are not done with the notes from these. I'm actually going to do this in 2 parts. We're doing part 1 today. This will be online later. We'll finish it up, do part 2 tomorrow. Feel free to start looking at the homework assignment for this section. We have covered how to do some of the problems. Feel free to try to tackle some of the problems we already talked about in the end that we've already covered.